All right, so once again, I would encourage you that if you're looking at this question in reference to it, I would look on your computer screen because it's in color to where this one is not in color. It's all in black and white, so it's kind of hard to distinguish between some of the graphs. Okay? And so the question says, select the graph that corresponds with this equation up here. Now, this equation up here, how is it written? What form is that in? It's a quadratic for sure, because we have a squared, but it's written in a certain form for the quadratic. Anybody know? This is referred to as vertex form. And vertex form was y equals a parentheses x minus h squared plus k. Now, let's talk about the different pieces of this. Okay? The pieces of this say that this and this is the x and y coordinate of the vertex of the graph. And the vertex of a quadratic graph is the lowest or the highest point, correct? And the lowest or the highest point comes from the value on the a being positive or negative. Okay? And so let's look at these graphs first off and see if we can identify from the graphs which one has the correct vertex or not, and we can eliminate some other ones straight off from there by recognizing the form. And so what is the vertex of this graph? From our equation, what is the vertex? Okay, for which coordinate? Okay, so we got a negative 2 in for the x, is that correct? It says minus 2 from there, so is that correct? Look at our form and look at what we have. If I have negative 2 for h right here, what's that going to do to the sign beside h? It's going to make it plus, right? And so therefore this isn't negative 2 for my x, it's positive 2, because if it was negative 2, that would be x plus 2 squared. All right, so what's my y value? Look at my form. Look at what I have. What's my y value? What was the one we said a while ago? It is negative 2 because that's a plus sign and that's a minus sign, so that is negative 2. Yesterday we talked about transformations a little bit. And in transformations, we can move a graph to the left or the right and up and down is what we talked about. Left or right deals with the x, up or down deals with the y, and those are the axes. But when we move on the x-axis, this is not going to be what we typically think. It's going to be a plus to the x. And this is going to be the minus to the x. On the y-axis, this is going to be a plus because it moves up, and this will be a minus and it'll move down. That's a memorization tactic we have to know. So when I look back up here again, inside my parentheses deals with my x, and that's a minus. So that tells me my graph is moving to the, since it's a minus, it's moving to the right. Okay, and since it's a minus 2 on the outside, that tells me it's moving down 2. Okay? And so from the origin, do I have a graph that's going from here 1, 2, down 2? Did I put a point on there? And isn't that the representation of the vertex? So how many graphs have that vertex? 3 of them. So the other ones that don't, I can eliminate them right off. So let's look at our answers a second. We see that graph A, B, and C have that vertex, right? So over here, I can eliminate graph D and graph E straight off, correct? So now let's look back at these. First of all, is this equation negative from the front? Is A negative? Is A negative? It is not negative, so therefore which graph has a negative graph on here? C does. So C is gone. Okay? And so what's the difference between A and B's graph? A is wider, B is more narrow. So therefore, we've got to see what happens from A. What does A's effect, which is our 3 on the graph, what effect does it have on the graph? Because we've taken care of the 2's, and 3 is the only thing that we've got to worry about. And what happens is this A is either going to make it more narrow or wider. And this is just like...
Make it like wider is when we talked about putting it in the calculator.
We did. We talked about putting it in the calculator. We put some numbers in, and we put a number in front of it, right? And so you could actually, from this point, plug that right there directly into your y equals and graph it if you wanted to look at it. And you would see a drastic difference between the two because we're only looking at 2 graphs right now. And so what I could do on my y equals is I could go up here and I could go 3 parentheses x minus 2 close parentheses squared minus 2 and hit graph. And from this point I could look at it, but that's also kind of tough to see because with my window fine, all that kind of stuff, okay? And so that's what we have for our graph. Which one do you say that looks like it represents?
B.
It does, easily, right? Because my A graph is going over into the other quadrant, and we see that it doesn't go in the other quadrant until late. So, what does a number in front of the A, or number in front at A, have an effect? If it's a whole number, what happens to the graph?
It narrows.
Right. If it's a whole number, narrow. What do you think will make it go wide?
Negative.
Not a negative. That flips it up or down.
Or 0.
Not 0, because that would make it not a quadratic. What's different than a whole number?
A fraction.
A fraction. Very good. So if something's a fraction or a decimal, it's going to make it wide. Okay? And so, with that understanding, our answer is B. Okay?